guys, welcome back to my YouTube channel. Today we'll be solving a question using inverse proportionality and proportionality. So first we're going to start out, what is proportionality? Now it's really just two of these values that are proportional to each other, like a fraction, and we're going to be using these two variables, a, and we're going to use these two constants, a and b. Now if for proportionality, a equals to k, the constant, times b. For inverse proportionality, it's the same thing, but vice versa. So a is going to equal the constant over b, which comes from 1 times k times 1 over b. So we're going to be using these two equations while solving this question over here. Now we are going to solve this question and read. I'm just going to choose the color green over here. We're going to be using different colors to color code today. So first, we're going to read this question. X squared is inversely proportional to y. Without reading the rest of this equation, we can already figure something out. So we learned about inverse proportionality. A equals to the constant over b. So what we're going to do is just plug this in. X squared equals to the constant 1, since we're going to be using other constants, over y. Now, we're going to write out the rest of the equation. We're going to leave it like that. We're not going to plug in any variables yet. So, z to the third is proportional to x, y. We're going to write this out because we know that a equals the constant times b. We're going to plug this in. It's going to turn out to be z to the third is proportional, which means it's k, the constant k, times xy. It's the second constant, oops. So, we're going to be using these two equations today. They're going to be incredibly important while solving these. I'm just going to choose the color red, and we're going to rewrite this. We're going to solve for y in this first equation. What you can do is that these two, they can just be flipped. X squared and y, they just change position because y is in the denominator and x is technically in the numerator since it's over 1. So we're just going to rewrite this as y equals to the constant 1 over x squared. And there, we just flip them over. Pretty simple like that. And it works because, well, if you do the math yourself, you should be able to figure it out. Now we're going to be using this to plug it into the second equation. So that's going to turn out to be z to the third is equal to the constant 2 times x times this value that we just solved for over here, the constant 1 over x squared. So now we're going to rewrite this because we can, well, I guess you could say you could distribute, but you're not really. You're just going to multiply these two together. You're going to get the constant 1 times the constant k times x all over x squared. We're just going to rewrite this equation back at the top so we have a little bit more space to work with. Now I know this might seem a little confusing since we're using a lot of constants and variables, but what you're going to do is just like k to the first, I shouldn't say that, constant 1 times the constant k. We're going to let that just equal to k. That this is a constant. And so if that happens, we can actually just simplify this down. And we're going to use a different color. I think we're going to use pink. Pink is nice. And what we can do is cancel out these two x's. And that's just going to turn into 1 over x. So k equals to x. K over x equals to z to the third. Because what this is actually saying is x to the first minus, well, divided by x to the second, which is really just their exponents minus each other. And that's going to equal x to the power of negative 1, which is equal to 1 over x, which is how we got the constant over x. So z to the third is equal to k, the constant, over x. I think it makes a little bit more sense now. We're going to use these values, x equals 5 and z equals 12. So 12 to the third is equal to 1,728, I'm pretty sure. So we're going to use that value, and we're just going to put it back into the equation. 1,728 is equal to the constant over, well, x is equal to 5, so we're just going to put 5. Now what we're going to do is going to be pretty simple. So we're going to try to cancel out this 5 by multiplying 5 to each side to keep it balanced. And what's going to happen here is that both of those 5s on the right side of the equation are going to cancel out. And 1,728 times 5 is 8,640. So that's how we figured out the constant. But we're not done yet. We still need to figure out what does x equal when z equals to 5. Well, we're going to use this equation that just popped right back up. Z to the third is equal to k over x to solve the rest of this, because we know the constant and we know what z equals. So this is going to be pretty easy plugging it back in. Just some basic algebra. Now that I've cleared up the board a little bit, we're going to see that z to the third is equal to 8,640, plugging in that constant variable over there. Constant equals over x. Now we know that z equals 5, so we're going to do 5 to the third. Now 5 to the third is 125, so that's going to equal 8,640, okay, give me a second, over x. Now, like I said, we can just swap those places because one is in the denominator, the other is in the numerator on this side of the equation. So x is going to equal 8,640 over 125, which simplifies to 1,728 over 25, which is actually equal to 69.12. So there you have it. We've solved this super easy proportionality question. Thank you, and please subscribe.